Hello everyone. Today I'll share how geographic constraints and a virulence-resistance trade-off shape the evolution of hypervirulent Klebsiella pneumoniae, focusing on the CC23K1 lineage, using a global genomic dataset plus targeted experiments. Klebsiella pneumoniae includes hypervirulent strains that cause community-acquired invasive disease and multi-drug resistant strains that dominate hospitals. Recently, hypervirulent carbapenem-resistant strains have emerged, challenging the idea that high virulence and high-level resistance rarely coexist. We analyzed 1,563 CC23 genomes and ran in vitro assays and a mouse model to ask, how is CC23K1 structured globally? Is carbapenem resistance stable? And is there a virulence-resistance trade-off, and by what mechanisms? For take-homes, CC23K1 shows strong geographic structuring with distance-limited spread, carbapenem resistance is repeatedly gained and lost, Asia favors high-efficiency carbapenemases, KPC/NDM, that often coincide with loss of virulence loci, while Europe is dominated by OXA48 which better coexists with virulence, and multiple lines of evidence support a mechanistic trade-off centered on the capsule and metabolic tuning. CC23K1 likely arose 170 years ago and diversified into 7 clades with clear regional biases, some enriched in East/Southeast Asia, others in Europe. Cross-border transmission declines with geographic distance, consistent with distance-constrained dispersal and local ecological barriers. This helps explain why resistance-virulence combinations cluster regionally. KPC/NDM are more common in Asia, OXA48 in Europe. Resistance is not stable. We infer over 100 independent acquisitions, mainly via plasmids, plus numerous losses, indicating rapid turnover. Regional plasmid ecologies and local antibiotic selection align with these patterns. At the locus level, KPC/NDM positive strains frequently show disruption or loss of key virulence loci, CPS, OPS, IRO, RMP, whereas OXA48 positive strains more often retain them. Mechanistically, our conjugation assays show that an intact capsule impedes plasmid transfer, while capsule impairment increases transfer efficiency. In vivo, strains with disrupted virulence loci show reduced lethality. Together, high-efficiency carbapenemases are less compatible with hypervirulence, whereas OXA48 more readily coexists with virulence. We detect enriched mutations in the phosphotransferase system, myoinositol metabolism, and electron transport chain components, NUA, MEN, with regional differences. A plausible interpretation is metabolic tuning that lowers ROS and improves tolerance to antibiotics and host stresses. This warrants further functional validation. To summarize, CC23K1 is geographically structured and spreads under distance limits. Carbapenem resistance is repeatedly acquired and often lost, and a capsule-centered trade-off helps explain why KPC/NDM frequently pair with reduced virulence while OXA48 preserves it. Core genome adaptations, metabolism, and the ETC may further modulate this balance. These insights argue for region and enzyme-specific surveillance and interventions. Thank you. I'm happy to take questions and can share data and code.